Hi. Hopefully, you're watching this because you missed class on Tuesday, May the 4th. So, let's take a look at what you missed so that you know what you can do for Tuesday and then can tackle Wednesdays. So, if you go to Google Classroom and you look at Tuesday, I might have moved this already, but the title you want to look for is Monday, Tuesday, and Wednesday work. I might have moved that up to Wednesday already. So, just look for this title. And what you're going to do is click on it and it's going to take you to this screen, one sentence summaries. So go ahead and click on that, and it's going to take you to something that looks like this. Okay. Basically, what we are doing today is kind of starting with something that's going to last over Tuesday and Wednesday. So here's what we did on Tuesday. Pretty simple. If you're a remote learner or you miss class, here's what you need to do. Go to slide 2 and copy down this information. You'll notice that mine looks probably different than yours. So we started yesterday by reminding ourselves what Newton's first law of motion is. So please type this into your sheet. Okay, and if you take a look at it, it says Newton's first law of motion states that an object in motion will stay in motion unless acted upon by an outside force. So if we think about that, an object wants to stay and keep moving unless there's a force that stops it. So think about a soccer ball that you kick across the field, right? The soccer ball wants to roll and roll and roll and roll and roll, but unfortunately it keeps touching the ground or the grass, hitting it, it causes friction, it slows it down, right? If we were to kick that ball in space, that ball would just keep going and going and going because there's nothing to stop it, okay? Same thing goes for the second part. An object at rest will stay at rest unless acted upon by an outside force. So the same thing goes for things at rest or for not moving, right? Like if I have, let's take this cup that I'm holding, right? This is at rest. It wants to stay at rest. It's going to stay at rest until I pick it up and move it and have it leave my hand, okay? And that's Newton's first law. You would see this a lot of times when you're moving or possibly in a car. So think about you're driving in a car and you're going 60 miles per hour, right? Newton's first law says your body's also going 60 miles per hour with your car. So if the car were to stop suddenly or hit something, your car hits and stops, but your body wants to keep going at 60 miles per hour. That's why we have things like seatbelts and airbags, because they're super important to make sure that we stay safe, right? So Newton's first law of motion, okay? Things that are staying or that are in rest want to stay in rest. Things that are moving want to stay in motion unless some kind of force stops it. And that force could be gravity or friction or some kind of collision. All right, so then what's really important about Newton's first law is that we also understand that Newton's first law is also called the law of inertia. And inertia is a little tricky to define, so we also talked about this. But basically, objects and things have inertia. So I have inertia, a giant truck has inertia, Dwayne "The Rock" Johnson has inertia, this bottle of water has inertia, and basically that just means how easy or how hard it is to keep something in motion or to get it out of rest, okay? So let's think about myself. I have inertia. My inertia is how hard it is to either to get me out of rest or to stop me if I'm in motion, okay? So you can see how it kind of goes with Newton's first law. So let's think of an example. Let's say that The Rock Dwayne Johnson is running at you and so am I, okay? And you have to be in charge of stopping both of us. Who is it going to be harder to stop in motion? Dwayne "The Rock" Johnson, because he's much bigger and he has a much larger mass. He just has way more body and weighs more and is stronger and has a lot more muscles than I do, right? So he has more inertia because if he's running towards you, he's going to be way harder to stop and slow down or keep from moving than I will be, right? Same thing goes for at rest. Let's say Dwayne "The Rock" Johnson and I are both taking a nap in our chair. Who is it going to be harder to physically move and get out of rest? It will be Dwayne "The Rock" Johnson. So it does depend on mass, okay? And it does depend on how something big is, which makes sense, right? If I had to pull a truck versus a bike, it's much easier to pull a bike than a truck. So it's gonna the truck is gonna have much greater inertia. So what we're going to do today, if you're an online learner, is please make sure you got this down. Okay, so stop the video and type this in. Then basically what we're going to do today is the first part of the directions. So all you're going to do today is you're going to watch all the videos on slides 4 and 5. All of them are tricks involving Newton's first law. And if you have the supplies, you can do them, but you don't have to at all, okay? We're going to be trying them at school on Tuesday. So all you need to go or do is go to slides 4 and watch all these videos. Go to slide 5 and watch these videos. And literally, they're like a minute or a little bit longer, really, really short. So watch all of these. Again, you can click on them and just, they'll start if you press the play. If for some reason, I know it doesn't work for everybody, I put all the links down on slide 6, okay? So that's all you're doing today. That's all you're doing on Tuesday if you're a remote learner or you're sick. You're copying down the definition of Newton's first law, then you're going to slide 4 and 5 and just watching the videos. Tomorrow on Wednesday, I'm going to give you instructions about how you complete the rest of it, okay? All right, good luck. Remember, I'm on Zoom if you need any help.